All right, so on this practice test, the first question is asking me if a license plate that is 6 characters long and is being from 8 numbers and 5 letters, how it matches up the following conditions. So the first important thing to note is that I have 13 total characters because I'm choosing from 8 numbers and 5 letters, so I added those two together to get the 13. A is asking me how many license plates can be made if the characters are repeated. So if I could have all of the same letter or some of the same letter, this one I would do 13 times 13 times 13 times 13 times 13 times 13. I do this 6 times because I have 6 characters, and I would just multiply that together. Another way you could do this is 13 to the 6th power. Both of them should give you the same answer. So if I go ahead, I will use my calculator. So I want to do 13, I'm going to do the 6, to the 6th power, which gives me 4,826,809. So that's how many possible combinations, if the letters are allowed to be repeated, that they can make for the license plates. If the license plates cannot repeat the numbers, that means once I pick a number or a letter, it is out of the running. So I start off with 13, but then I lose one each time. So I have 12, 11, 10, 9, and 8. I want to have 6 numbers because I had 6 characters. So I count down until I have 6 of these, and then I will go ahead and multiply all of those together. I'm going to do 13 times 12 times 11 times 10 times 9 times 8, which gives me 1,235,520. Okay. Number 2 says, after the quarantine, I plan on hosting a birthday party for my cat. I have invited 7 family members to the party. How many possible ways are there for them to arrive if they all arrive one at a time? So I know all of them have to come, and I know order matters. So I can do 7 factorial to get my answer. If I am using a TI-84, I would type the 7, then I would go to the math key, which is right under the alpha. I would arrow over to probability, and I would choose the factorial choice, which is choice number 4, and then I would press enter to get my answer. If I was using a TI-30, what I would want to do here is I would type the number, and then I would hit the PRB button, which is diagonal from the second, and then I arrow over to the exclamation point for factorial, and then I press enter. So this answer is 5,040. Number 3 says, I've decided to start playing the lottery to buy a new pool. I don't care if I win the jackpot. I just want to win the second place prize, which is $1 million for getting the 5 white Mega Million balls right. Each number is only called once. There are 70 white balls and 5 are chosen. How many possible outcomes are there? For the Mega Millions, when numbers are called, it says the order doesn't matter. So I will have 70 choices for my balls, and then I only want 5 of those. So I'm going to do a combination here. To do that on the TI-30, I would type in 70. I hit the PRB button, and I arrow over to NCR and press enter, and then type in 5. I would do similar on this calculator. I would go 70, go to math, arrow over to probability, and then pick the NCR choice and type in 5, which gives me 12,103,014. Yeah, 1,000. No, 12,103,014. So there's that many possible outcomes. Okay. Number 4 says, I've gotten really hungry writing the test, so I've decided to order some pizza. There is a deal going on right now that if I order a 2-topping pizza. The pizza place I'm looking at has 12 different types of toppings. How many different combinations of pizza can I choose from? So this one, again, the order I pick my toppings in doesn't matter, but it does matter that I pick 2. So I have 12, choose 2 for combination. I'll just do this on this calculator since it's the same process as the last problem. So I go 12, and then I choose NCR, and then I type in 2 to get a total of 66 choices. Number 5 says in one of my high school classes, I have 13 girls and 15 boys. I want to make a new seating chart and seat the kids in groups of 4. If I want to have 2 girls and 2 boys at the first group I make, how many different groupings can I have? So I know I have 13 girls, and I want to choose 2 of those. And then I have 15 boys, and I also want to choose 2 of those. Because I want them to be in the same group, I have to multiply them together. So I am going to do, 13. Choose 2. On a newer TI-84, I will need to arrow over and do the multiplication sign. If I was on an older one, I could just type the multiplication sign. Then I'm going to do 15, NCR, and then 2. And this gives me 8,190. That's how many different possible combinations I can make with those sets of students. Next question is asking me to find the probability of rolling a number less than 3 on a dice. So I'm just looking at a single dice. These are labeled 1 through 6, and numbers less than 3 are just 1 and 2. So I have 2 choices out of 6, which simplifies to 1/3. Next problem is going back to my cat's birthday party. There are 10 gifts, 4 wrapped in wrapping paper, 2 are wrapped in a gift bag, 3 are unwrapped, and 1 is a gift card. What is the probability I will choose a gift that is not in the gift bag? So I can either add up all of the non-gift bag numbers, or I can subtract from 10. I am going to subtract from 10. So I had 10 total gifts, and the not in a gift bag, so there were how many in a gift bag? 2, over a total of 10. Then I just simplify. I get 8/10, which simplifies even more into 4/5. The other way I could have done it, I'll do this one in red to show you. Maybe I won't do it in red. I lost my red pen. Oh, here it is. The other way I could have done it was I could have added the other choices together. So I could have added 4, 3, and 1, because there was 4 wrapping paper, 3 unwrapped, and 1 gift card, and divided by 10. It would give me 8/10 again, which would also simplify to 4/5. Okay. Number 8 says if 2 dice are rolled, find the probability that the sum of the numbers adds to 11. Whenever I have 2 dice that are rolled, and I'm looking at their sums, it's out of 36 because I have 6 possible choices on each side of the dice. I want to find the probability that the sum of the numbers adds to 11. So that would be things like 5 and 6, and 6 and 5. None of the other dice pairs add up. So I have 2 out of 36 choices, which will simplify to 1/18. I forgot to say this, but if I wanted to check this on a calculator for simplifying, I would do 2/36, and I press enter. Then on the TI-83 and 84, I go to math. My first choice is fraction. I press enter again, and it gives it to me as a fraction. If I am on this calculator, I would do 2 divided by 36 and press enter. And then right above the PRB button is an F to D arrow. I would go second, F to D, and then press enter, and it gives me 1/18. Okay. Number 9 is going back to my cat's birthday party. I'm giving out party favors. In each bag, I'm putting cat stickers with either a photo of Kiki sitting at the table or Kiki playing with bubbles. I have 6 photos of Kiki sitting at the table and 7 of her playing with the bubbles. I have 3 sets of stickers left. What is the probability I will pick 3 photos of Kiki playing with bubbles randomly? So for this one, I have 7 plus 6 total photos, which means I have 13. I want to pick the ones of her playing with bubbles, so that was the one out of 7. I have 7 over 13 to start with. Then when I put one in a bag, I assume I got what I wanted. So there are 6 choices or 6 stickers with Kiki playing with bubbles left, and there are 12 total stickers left. I go again one more time. There are 5 stickers left of Kiki, and there are 11 stickers total. Then I just want to go ahead and multiply these 3 fractions together. So I would do 7 divided by 13 times 6 divided by 12 times 5 divided by 11. 11 gives me a decimal. I can turn this back into a fraction, and it turns out to be 35 over 256. Okay. Number 10 wants me to find the odds in favor of pulling a heart from a standard deck of cards. Remember, odds are not the same as probability. Odds are when I am comparing 2 things together. So odds are what I want compared to what I don't want. There are 13 hearts. And if I want to know what's not a heart, I would take 52 and subtract the 13, which gets me 39. So there are 39 other cards. For odds, I can write this as a fraction. I have 13 cards I want compared to 39 cards I don't want, I mean. Then I can simplify this on the calculator. So I would do 13 divided by 39. And then it gives me a decimal. I go back to math, fraction, which gives me 1/3. So this isn't saying I have a 1/3 chance. This is just saying for every 1 card that's a heart, there are 3 that are not. It's a comparison. Okay. Number 11 gives me my answer, or gives me my value as an odd, and it wants me to turn it into a probability, and it wants it as a decimal rounded to 4 places. So when I'm turning it back into a probability, I keep my first number on top, that stays, and then the bottom gets the 2 values added together. So I want to go ahead and add the 24 and 65 together. If I'm going to type this straight into the calculator, I want to remember to put those 2 in a set of parentheses. So I would do 24 divided by parentheses 24 plus 65 and close off my parentheses, which gives me 269, and then I have a 6 with another 6 after it. So I would round that first 6 to a 7 because I want it to 4 decimal places. Number 12 says I'm still looking at getting money to build my pool. I was looking at entering a raffle where the grand prize was $7,500. If it costs $5 to buy a ticket and they sell 1,000, what is the expected value of my ticket? Okay, so here if I win, I don't actually win the full 7,500. I had to pay $5 to get that. So I want to figure out the true value of winning. So I take the 7,500 and subtract the $5 that I will win, which gives me 7,495. So that's how much I actually win if I win. And there's only 1 out of 1,000 possible tickets that will give me the winning value. Then I know if I lose the $5 I paid. And for losing tickets, I take the 1,000 and subtract the 1 winning ticket to get 999 losing tickets. So I will multiply the -5 by 999 over 1,000. I'm just going to draw a line there so I don't get confused. Then I just type this straight into the calculator. So I would do 7,495 times 1 over 1,000 plus -5 times 999 over 1,000. 1,000. Okay. And this gives me 2.5. Remember, we are talking about winning money. So I would turn that into $2.50 is the expected value of each ticket. So if I bought all 1,000 tickets, on average, I would earn $2.50 per ticket. Number 13 wants me to consider a standard deck of cards and find the probability of pulling a spade or a queen from a standard deck of cards. So there are 13 spades out of 52. There are 13 queens out of 52. I need to check to see if cards can be a spade or a queen, and they cannot. But if I had an overlapping set, I would subtract it from what I just added because I don't want to double count it. So here I'm going to add. I get 26 over 52, and that simplifies to 1/2. Okay. Number 14 says I'm pulling M&Ms out of a fun-sized bag that I have left over from Easter. It has 5 pinks, 2 greens, 4 purples, and 2 yellows. I want to find the probability that the one I grab is either pink, yellow, or green. So first I need to find out how many total M&Ms I have. I have 5 pinks, 2 greens, 4 purples, and 2 yellows. If I add those all together, I get 7, 11, 13 M&Ms. And then I want to find the probability that it's either pink, yellow, or green. So I have 5 out of 13 pinks, 2 out of 13 yellows, and 2 out of 13 greens. So if I add those together, 5 plus 2 is 7, plus 2 is 9 out of 13 of those choices are either pink, yellow, or green. Oh, I still want this kind of up there. B says that say I pull one M&M out of the bag and then I put it back because someone starts talking to me. Once I leave, I grab another M&M. What is the probability both are pink? So I know to start with, I have 5 out of 13 pink M&Ms. I'm going to multiply this by the next choice. Because I put the M&M back in the bag, that means there are still 5 out of 13 M&Ms in there. So I multiply it by 5 over 13. Then I multiply and I get 25 over 169. This one, I just want to double check to make sure it doesn't simplify. It does not. So this is my final answer. C says that instead of putting the M&Ms back, I chose to eat it. So what are the chances that I pull out 2 pink M&Ms? So the first try is still the same. There are still 5 out of 13 pink M&Ms in the bag when I start. I eat that pink M&M in my hand, so now there are 4 pink M&Ms in the bag and a total of 12. Then I'm going to multiply this one on my calculator. So I have 5 over 13 times 4 over 12. Go and do math fraction, and it turns it into 5 over 39.